Okay, next we come to Philippine Tektites. Philippine Tektites, same as all these Tektites, originally started off as spheres, dumbbells and teardrops. In the Philippines, much fewer teardrops and dumbbells, mainly spherical forms. The vast majority were smaller sized spherical forms or medium sized spherical forms. Remember now we're moving away from the impact. Indochinites were very close. Philippinites, say a couple of thousand kilometers from the impact. So we're moving away there. These are re-entering as solid, brittle tektites now. They're no longer molten. They possibly have some degree of maybe not totally brittle, totally solidified on the interior. That's a possibility, but effectively the bulk of it is now solidified. These ones, the commonest ones, are the biscuit forms. Grooved on one side, this is the anterior, smooth posterior. There it is, it's effectively a core, we call it a biscuit. This posterior, measure the shape of that and you get the original sphericity of the body. Maybe 70% has been lost to spooling as it's re-entered. Remember, these are glass. When you heat glass, it explodes, it fragments. These are some quick experiments that I did. I'd like to show you the clips, but unfortunately I've struggled with the format that I filmed them in, so maybe I can't. But this is a piece of glass that I just heated on the gas stove. Originally it was a sphere, but you heat it, the glass explodes away. I end up with loads of fragments of glass. So that's effectively how a core is formed. These were hollow glass spheres that I heated up just very gently, and you get these polygonal cracks forming. That one's actually exploded out. So this is interesting with the polygonal pattern forming. It's perhaps suggesting that maybe on some of these Philippinites they were still slightly hot or slightly less brittle on the interior, which is probably what you would expect, but certainly very brittle on the exterior. So these are hollow spheres. Something with a more slightly molten interior and brittle exterior would behave in a similar way to a hollow sphere as opposed to a core body, a solid brittle glass body. So right, back to the tektites. Basically we'll ignore the teardrops and dumbbells for now. They're relatively unusual in the Philippines, and their mode of formation is obvious once you know the mode of formation of the spherical bodies. So size is important on the spherical bodies. Most of the tektites, the vast majority, entered as oriented forms, and we're looking at these biscuits. These are pretty common. Got bucket loads of these. In fact, I don't want any more. I'm getting delivered so many. These re-entered the atmosphere like that in a very oriented fashion, and the glass exploded off as it was heated unevenly, the back remaining cool, the front getting superheated by a frictional re-entry heat. Interestingly, these ones, if you measure the sphericity, form basically from the same size sphere as the bread crust forms. This is bread crust form. So why do we get bread crust forms and biscuit forms? The reason is these bread crust forms, although they're formed from the same size body, were probably rotating as they entered the atmosphere. They weren't oriented, and because they were rotating, the frictional heat is distributed over the whole of the surface of the body. It's heated up more evenly, and it's not heated up to the same degree as these ones, which just have one surface showing facing the frictional heating. So these ones probably entered rotating. At some point probably something did spool off. At that point it's not a perfect sphere anymore. It's going to want to establish an orientation, and that's why often these are not perfect spheres. They start to lose some of the shell there, And you know, ultimately you're looking at something like that. That was probably originally a very nice biscuit, but now you've kind of got a nucleus or sort of core there, and this would be the posterior here. So that one probably established some kind of orientation fairly early on.